and Howard Rafe invited me to make a presentation in a session at the Boston, back to Boston again, I think it was an ORSA meeting. He was the chair of the session. And so I said I'd be happy to do that, and I had to choose a title. And so I chose Decision Analysis, Applied Decision Theory, or as we call it now, DAAPDT. Now, I didn't really like, I was thinking of decision engineering, which would be more descriptive, but that sounded manipulative. You know, we're going to engineer your decision. It's going to come out the way we want it to. So I stuck with decision analysis. Okay, now who has read that paper? Not everybody, right? You may have heard about it. Well, I decided to go through and take a look at it again and see how time has dealt with what I wrote. Now, as I said, I'm not going to talk about, what were the distributions and blah, 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 the methods, but just some of the more general things. And so I'll quote, I'm reading from it now. The purpose of this article is to outline a formal procedure for the analysis of decision problems, a procedure that I call decision analysis. We shall also discuss several of the practical problems that arise when we attempt to apply the decision analysis formalism. Now, these are paragraphs. This is not in succession paragraphs, just sample paragraphs. Decision analysis is a logical procedure for the balancing of the factors that influence a decision. The procedure incorporates uncertainties, values, preferences, and a basic structure that models the decision. Typically, it includes technical, marketing, competitive, and environmental factors. The essence of the procedure is the construction of a structural model of the decision in a form suitable for computation and manipulation. The realization of this model is often a set of computer programs. Another paragraph. Having defined a decision, let us clarify the concept by drawing a necessary distinction between a good decision and a good outcome. No kidding, right? Why didn't anybody ever think of that? A good decision is a logical decision, one based on the uncertainties, values, and preferences of the decision maker. A good outcome is one that is profitable or otherwise highly valued. In short, a good outcome is one that we wish would happen. Hopefully, by making good decisions, in all the situations that face us, we shall ensure as high a percentage as possible of good outcomes. We may be disappointed to find that a good decision has produced a bad outcome, or dismayed to learn that someone who has made what we consider to be a bad decision has enjoyed a good outcome. Yet, pending the invention of the true clairvoyant, he was there too, we find no better alternative in the pursuit of good outcomes than to make good decisions. Further on, another criticism is, if this is such a good idea, why haven't I heard of it before? Did that ever happen? Yeah, no. We're talking 1950, 1964. One very practical reason is that the operations we conduct in the course of a decision analysis would be expensive to carry out without using computers. Think about that. In that first decision analysis, in order to do a calculation, you had to carry it to the high priest of the computing department. Okay, this was just beyond the punch card era. When I was a doctoral student, I carried my punch cards to the sacred machine at MIT, and you did your bows and so forth. But this was not that much later, and even at a company like General Electric, which made computers, you didn't do this yourself. You had somebody who served you, or maybe you served them. Can you run this again? I mean, you remember yesterday, I can't do the simulation as fast as, I can't get my button, figure out the button as fast as it does know the 3000. Oh man, this is like your father telling you how far he walked to school. They must have gotten great exercise in the old days. Okay. Okay. It's a good idea. One practical, we wouldn't have computers. To this extent, decision analysis is a product of our technology. And I'll just insert there, think about what Laplace would have done. If you read his books, the major one on probability and the others on decision making and more common everyday life, annuities and things like that, think of what he could have done if he had had a computer. And sometimes I say, suppose he arrived, he suddenly awakes 200 and 2 years later, or something like that, and he says, oh, guys, look, I thought that you'll be doing this now. I mean, what do you use for computation? I mean, do you have something better than the abacus? Oh, yeah, man, look at this, zip, 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 zip. And he said, what's your excuse? I had all the ideas, and it was 200 years ago. That lets me another story of how long it took me to get a copy of his book from the libraries of the United States. Most important book on probability ever written. But another story, not going to get into that. Anyway, what's our excuse? To have this computational ability and not be implementing the things that he foresaw over 200 years ago. Okay, there are other answers in addition to the technology. One is that the idea of probability as a state of mind and not of things is only now regaining its proper place in the world of thought. Boy, was that optimistic. Only now? Yes, right. The opposing heresy lay heavy on the race for the better part of a century and a half. We should note that most of the operations research performed in World War II required mathematical and probabilistic concepts that were readily available to Napoleon. Okay? Even that was not new stuff. By the way, Laplace's book on probability was dedicated to Napoleon in the most obsequious fashion. One wonders about how the introduction of formal methods for decision-making at that time might have affected the course of history. Well, guess what? We're still not doing it. We still have the decider who probably has never seen a probability distribution in his life. Thus, the decision analysis is a vital structure that lets us compare at any time the values of such alternatives as acting, postponing action, and buying information, or refusing to consider the problem further. We must remember that the analysis is always based on the current state of knowledge. Overnight, there can arrive a piece of information that changes the nature of the conclusions entirely. Of course, having captured the basic structure of the problem, we're in an excellent position to incorporate any such information. Here we go. One aid in reducing the problem to its fundamental components is restricting the vocabulary that can be used in discussing the problem. Thus, we carry on the discussion in terms of events, random variables, probabilities, density functions, expectations, outcomes, and alternatives. We do not allow fuzzy thinking about the nature of these terms. Thus, quote, the density function of the probability, end quote, and, quote, the confidence in the probability estimate, end quote, must be nipped in the bud. We speak of assigning, in quotes, not estimating probabilities. The probabilities of events, and think of this assignment as based on our, quote, state of information, end quote. These conventions eliminate statements like the one recently made on a TV panel of doctors who were discussing the right of a patient to participate in decision-making with respect to his treatment. One doctor asserted that the patient should be told of, quote, some kind of a chance of a likelihood of a bad result, end quote. You ever have a doctor who talks to you like that? I'm sure the doctor was a victim of the pressures of the program, would agree with us that telling the patient the probability the doctor would assign to a bad result would be preferable. One of the most important advantages of decision analysis lies in the way it encourages meaningful communication among the members of the enterprise because it provides a common language in which to discuss decision problems. Thus, engineers and marketing planners with different jargons can appreciate one another's contributions to a decision. Both can use the decision analysis language to convey their feelings to management quickly and effectively. There are examples of that in the paper. Other arguments over which is the best decision arise because the participants do not realize they're arguing on different grounds. Thus, it is possible for A to think that a certain alternative is riskier than it is in B's opinion, either because A assigns different probabilities to the outcomes than B, but both are equally risk-averting, or because A and B assign the same probabilities to the outcomes but differ in their risk aversion. If we are to make progress in resolving the argument, we must identify the nature of the difficulty and bring it into the open. Similar clarifications may be made in the areas of time preference or the measurement of the value of outcomes. Now that confusion between is the riskiness of the deal in the information leg or in the preference leg, that came up with the board much after this was written. For example, though we have tended to think of utility theory as an academic pursuit, one of our major companies was recently faced with the question, is $10 million worth of profit sufficient to incur 1 in 1 million chance of losing $1 billion? Though the loss is staggering, it is realistic for the company concerned. Should such a large company be risk indifferent and make decisions on an expected value basis? Are stockholders responsible for diversifying their risk externally to the company, or should the company be risk averting on their behalf? Now, we've all thought about these things. For the first time, the company faced these questions in a formal way rather than deciding the particular question on its own merits, and this we must regard as a step forward. Oh, yeah. Okay. And finally, decision analysis is no more than a procedure for applying logic. The ultimate limitation to its applicability lies not in its ability to cope with problems, but in man's desire to be logical. Guess what? Still true.